Domain and range. So this is something, you really seen this before. You just called it input and output. But domain and range is pretty much just looking at all of our X values and all of our Y values. So that's what goes here. Domain is all possible X values and range is all possible Y values. So I'm going to just put the words you've seen before. You've seen input and you probably have seen independent variable before. And then range would be output, dependent variable, and that's that. Okay, so in a question they can ask you to find the domain, they can ask you what's the input, they can ask what's the independent variable. They're asking you the same question, so these words are synonyms. So when you talk about continuous and discrete data, continuous will be data that you can measure. So we can have in-betweens here. Discrete will be data that is counted as separate. Okay, so an example, and if I look at, let's look at discrete data first. Okay, that's something that I cannot split. So if I'm talking about the number of students in my class, okay, I can have 20 students, I can have 21, so on and so forth. But I cannot have like 21.3 students, okay? Nobody is a 0.3 of a student, okay? So that will be discrete because it's whole numbers only. It's not going to be any fractions or any decimals included with discrete data. So again, some example could be a number of students. I can say number of concert tickets, because if I go to a concert, I'm gonna ask for like, hey, I want 2 tickets for tickets for me and my mom or me and whoever. I'm not gonna say, hey, give me 2.5 and they just rip it in half and be like, okay, here you go. No, okay, it has to be a whole number. So when we say continuous data, we're talking about data that can be measured. Okay, so let's say I'm talking about time. Okay, let's say I'm running the track and I'm timing the distance that I went or the time that it took me to run a lap. Okay, I can say I ran a lap and maybe it'll take me 4 minutes. I don't know, I'm kind of slow, but I can say it took me 4 minutes to run a lap, right? But my question is, can I have in betweens? Can I run in 4.5 minutes? Can I run in 4 minutes and 2 seconds? Okay, so since I can split it, and of course, you know, time, it goes, you have different increments of time, hours, minutes, seconds, and all those things. So things that you can break up and measure will be continuous data. So I can say time, I can say length. Because if I was to measure my desk, I can say, okay, my desk is probably about 6 feet and 3 inches long. Okay, so I can have in-betweens. So that would be continuous data. Now with your graph, what you will see is that it's not going to have any breaks in it. So you may see a curve or you may see a line. That just means that it's going to continue from one interval to the next. Discrete data will be when you have your scatter plot, okay? Because remember, we said that it's separate. So each of these points stand on its own. So when you're looking at a scatter plot, that's going to be your discrete data, okay? So when you're dealing with domain and range, they can ask you to find it from multiple representations. So that's ordered pairs, tables, mapping, word problems, and graphs. So I'm going to just show you how to do all of them. And then we'll go from there. So they're pretty much asking you what's the X and what's the Y. What are all the X values and all the Y values, all the possibilities. So with ordered pairs, of course, you know, the first one is X and the second one is Y. So I'm just looking at what are my X values: 5, -1, 0, -2. And I just write those down. Okay. Now you do want to go in order. So I'm going to have -2, -1, 0, and then 5. Okay, so when I say order, that means you're going to go from least to greatest. Okay, and you're going to draw brackets. I'm not really good at drawing this, but you get the picture. It's this symbol that's right here. That's what I'm trying to draw. So don't laugh at me. My range, that's going to be my y, like we said. So that's going to be -7, 4, -5, and 3. So I'm going to just write -7, -5, 3, and 4. And that's my range. Okay, tables are pretty simple. This is going to be my domain, my x. Okay, and this is going to be my range. Okay. Okay, so I'm going to have -2, 4, 7, and 8. Okay, then here I'm going to have -6, -3, -1, and then 9. Okay, my brackets are just getting worse and worse. All right, so for my mapping representation is the same exact concept. So my domain is here, -5, -4, 2, and 3. And my range is here, 1, 6, 9. All right, so these are the ones that you may find pretty easy because you're just looking at the table and the numbers are already there. Now the graphs get a little tricky, okay? So make sure you're paying close attention here. If you need to rewind and go back, please do that. So on the front and on the first page, I had your inequality symbols. So when you're dealing with an inequality, or when you're dealing with a continuous graph, you're going to be dealing or writing your domain and range using inequality notation. Okay, so I want to see, where does my graph start and stop? Okay, where does it start and where does it stop? So domain is my x, which I'm going to look at my x-axis. We know that the x-axis goes from left to right. So I need to see, where does this graph start? So I'm going to draw a line here. Okay, and I'm going to label this x because we're drawing a line through the x-axis because that's what we're trying to find. So it's starting, if I count, it's starting at -7. I'm going to draw a line where it stops. Again, this is my x because I'm finding domain. So I drew it through my x-axis. And this line is where x is equal to 5. So what I'm doing is I'm just creating boundaries for my function. Think of it like a fence. I'm kind of fencing off this graph. And I want to make sure my image or my graph is inside those boundary lines. So when I actually write out my domain, I'm going to put my lowest number first. And I'm going to skip some space and put my biggest number or my maximum. My x is going to go in the middle. And what's going to happen is you're going to be creating, or you're going to be writing out what is called a compound inequality, which means it's going to be 2 inequalities in 1. So we know that our numbers, like if I look at 5, it's going to the left of 5. So that means that my numbers are less than 5. But we see that they're bigger than -7. So I'm going to put another less than sign. And it's less than because it's open towards the x. So that means that these numbers are greater than x. Okay. Just a little hint, whenever you're dealing with domain and range and you're writing compound inequalities, they're always going to face this way. So you're always going to have less than signs, always, unless you're dealing with a singular inequality, which that can go either way. The only thing you need to determine is, does it get the equal to? So we have an open dot on 7. So this is going to get an equal to. And 5, we have a closed dot, so that one is going to stay like it is. And the way this is read, my x values are all real numbers that are less than 5 and greater than or equal to -7. Okay, let's look at our range now. So range, I have to start from the bottom because our negative numbers are at the bottom. So this number here, this is -3. Okay, so I'm drawing a horizontal line because I wanted to go through the y-axis. And then here, I'm gonna draw another horizontal line where it's stopping, okay? And that's at 1. So then I'm saying, okay, my graph is going from -3 to 1. So I'm gonna put my smallest number here and my biggest number here. This time it's gonna be y because it's range. Again, like I said, we're always gonna have less than signs. So I'm gonna look at 3 right here, and we still have that open dot, closed dot. So we're gonna put a equal to there, and the 1 has an open dot, so we're good to go. Okay, and that's it. That's how you find your domain and range given a graph. Okay, and this is a continuous graph. Okay, it's continuous because from one interval to the next, it's no breaks in it. Okay, why did I put an E there? Continuous. Okay. All right. Let's look at this next one. So same thing, X. This time it's starting at 0. And I'm ending with an arrow. An arrow indicates that it's going to keep going. So keep going in math means infinity. So I'm going to put an infinity sign. Okay, so that means it's going from 0 to infinity. So this actually means that my domain is all real numbers greater than or equal to 0. So 2 ways I can write it. I'm going to have the X in the middle. Like I said, I'm going to have my inequality signs. And then I'm going to have equal to. Okay, or you can write my X values are greater than or equal to 0. Now, the reason it gets the equal to is because we don't have any dots, so that means that that number is included. So it's equal to at that given number. All right, for our range, bottom to top. So it's arrows on both ends. So it's going from infinity to infinity. So what that means is it's all real numbers. Or you may see them write infinity to infinity like this. Okay, so make sure you know that those are the same. And this is also a continuous graph. This next one is a discrete graph. We know that because it's a scatter plot. So these are a little bit easier because I'm just gonna write my brackets and I'm gonna put where it's going on the x-axis. So this is -3. This dot here is -2. This dot here is going to 1. This dot here is going to 2. And this dot here is going to 5. Okay, for my range, same thing, but the opposite. So this is -5 on my y-axis. This is 0. This is 1. Notice it's 2 dots here. I only need to write that 1 time. Then I have 4. All right. So last part is our favorite, our word problems. Okay. So it says Miles received a $15 gift card to download music. Each song costs $1.50. So X is going to represent our number of songs, and Y will represent our amount left. So each time he buys a song that's on this $15 gift card, it's going to be taken away from the total amount. So how many songs can he buy? We want to think about what's the maximum amount and what's the minimum amount. So we know he can buy 0 because he can get the gift card and he could decide to just not use it, right? Okay. The max would be 10 because if I divide 15 divided by 150, that'll give me 10. Now the thing is, this is a discrete situation because he cannot buy half a song. He has to buy 1 song, 2 songs. He can't buy 2.3 songs. So I'm going to have 1, 2, 3, 4, 5, 6, 7, 8, 9.